the groundwater. And now you can see that what happens sometimes is that here we can still see the source, but with time the plume could actually separate from its source once the source stops leaking, but you'll get the plume that's moving along, and so it may go miles before it might be detected in a well. And so this is one of the things, getting an understanding of why we have to protect certain areas from the potential for these areas to disturb an aquifer. Particularly there's areas called sole aquifers. Cape Cod has a single aquifer that goes down Cape Cod. So there needs to be a protection of that, because there's areas that can result in pollution to that aquifer. And there's also zones of influence around a well. When we pump a well, what happens is it creates a cone, and this cone spreads out as we're pumping. So based on the pumping rate and where that zone of influence is, what we'll do is we'll say areas of groundwater protection, wellhead protection areas, so that as long as it's in that zone, anything coming in that zone can be sucked into the well. And it's not just, even though the water's traveling in this direction, because the well's pumping, it's going to be drawing water from both directions. So if there's pollution over here, you say, well, the water's going down that way. But based on the well, it could suck the pollution into that well. One other thing that we can also do is measure the amount of water that's flowing through an aquifer. And this is a little more consuming. We have to determine the porosity, how much water is actually in this area. And to do that, we can look at some of these soil samples. These are samples of material in the aquifer. This is the material here, then we have some of the material up here, and then this is this one's actually in the confined aquifer here, and this is the one in the confined, sorry. There's an unconfined layer here, which is made of this material. There's a confined area here made up of finer material, and then there's the confined aquifer made up of this coarser material. And so what we would want to determine is, based on the volume of this, we know we can calculate the volume of this cylinder and how much material we have, and then we can add water in here slowly so that it fills up. And that would determine, in this particular volume, how much water is present in that particular volume of soil. And so we can calculate the area in a certain area here, and then by knowing the volume of water in here and the speed that it's traveling, we can determine the flow of water through the aquifer. And so again, this is many exercises that we can do with this. There's also a septic tank right here that we can study the effects of a septic system. We add a little dye into there. You can see this is the leaching field right here. And one thing you want to make sure, we can adjust this so that the leaching field, the water level is lower. You want your leaching field so that it's below the water level. Right here we have the water level. And now you can see how it goes into the soil from the leaching field. But this is also an area of biological activity. And so the water is being treated by this. And then the water makes its way, you can see it's making its way over to the lake. So that's why it's important that septic systems be maintained. because when we have the leaching of the water down there, if the water level is too high and there's not enough of a biological zone for the water to be treated, it can travel into the lake and pollute the lake or pollute a stream. So you can see I dropped the water level here, so you can see how it's passing through and moving down from the leaching field through this biological zone here where the treatment takes place, and then you have your heavy material stays in the septic system. The lighter water or the thinner water will pass out through your leaching field and then be treated. And septic systems, if they're maintained properly, can work as well, sometimes even better than a wastewater treatment plant. So it's just a matter that they have to be maintained. And make sure that these aren't getting clogged, make sure you have a proper level for the biological zone, and also that you pump your sludge out so that your sludge doesn't end up moving down into the septic system and blocking the pores that are in the leaching field tanks. And so I hope you get to come into class, into lab, and use this device, because it's a lot of fun and we can gain a lot of information from it. So have a good day and look forward to seeing you.